Welcome to these presentations. My name is Benson Kituku. I'm going to present on the title Leveraging on Cross-Linguistic Similarities to Reduce Grammar Development Effort for Under-Resourced Language, and I take a case study of Kenyan Bantu language. While we are in a technology-driven economy, and therefore we require these natural language resources, applications, tools, or grammar, and these would help us to reduce the technological digital divide gap between the under-resourced languages and rich resource languages. Here we take a case of banned languages, which are of course under-resourced. They have complex morphology, and most of them are spoken. They are agglutinative in nature, that a word consists of several morphemes which are conjunctively joined together. And we take Kenya, there are around 25 of these languages. So far, two main approaches have been used to generate tools for natural language processing. There is the data-driven approach, but in the terms of Bantu, uh, because of that agglutinative in nature, the morphemes dependence between them are not captured by this method. And again, these are mostly spoken languages, therefore the corpus is not there, therefore we'll need to create a corpus that which is an expensive endeavor. And definitely there are some corpus that exist, but they have data sparseness, hence they cannot bring reliable results if they are used. The alternative is the rule-based approach. However, use that way it will be labor intensive in terms of human expert, in terms of knowledge, and making of the tool will be slow. Therefore, a solution to this is to utilize the cross-linguistic similarities which exist because Bantu exists as a family, and they follow the universal grammar concept where there are common principle or structures, features, and specific parameters which control the service phenomena. And of course, in line with sustainable natural language process grammar development, these we need to leverage on them, on the cross-linguistic similarities, in order to create a shared grammar, and then we leverage on the shared grammar in order to bootstrap other grammars. Therefore, we propose to develop a Bantu parametric grammar in a multilingual ecosystem, and then using or utilizing the cross-linguistic parameters based on grammar sharing or grammar porting, uh, where in this case, grammar sharing is where we look at what is common among different language grammars and we make it as one unit, while in grammar porting, it's where the structures are similar, but the content may be different. So we adopt the structures. And then after that, the shared grammar will be a seed for bootstrap. Then we can bootstrap another language or another grammar for that matter. In this case, we use the grammatical framework. One, because of its ability to separate the concrete syntax and abstract syntax. That's a plus. It's also a multilingual system. And again, beyond that, once a grammar is created, on top of it, you can create controlled grammar. So that's 100 plus. So very soon we have used a grammatical framework. And a grammatical framework, of course, it's based on one abstract and main concrete syntax which represent the languages. You can see here these are abstract and these are concrete for Spanish and these are concrete for English. And uh, to move from concrete to abstract, you analyze, then from abstract to concrete, you pass. And these concrete grammars are stored in resource grammar library. The abstract, of course, consists of categories and functions of trees for the categories, while concrete syntax will show how to realize as a category and the components of category. Now, grammatical framework as a module referred to as a factor or parametric modules where you define a shared grammar and then the unique components are stored here. So it's a functions where all the shared are here and then uh, the unique one for the grammar here. In the approach to develop the boundary parametric grammar, uh, we approached by setting up an experiment. And in this experiment, basically, there were the regular expressions of paradigm in regard to the word used in grammatical framework. There were the rules, there were the categories and how to linearize them, and the parameters in question. First, the grammars and for the language that is Ekikusi and Kikamba were developed independently so that not to bring any biases when making this band parametric grammar. Now, in the approach, we use the morphology driven approach. In this matter, you define the lexicon, which grammatical framework provide 500 of them for a start, and you can create more at the dictionary level. Then after that, you create a morphology of the how these each category. If you take a noun, you create the regular expression on the inflection of noun, and thereafter you create the syntax. We used evolutionary prototype design in creating the regular expression or the function for each rule. This because we want to make sure the function works. We do test it and then see it produce the required result. So in this setup, we had the generalized grammar, which included the principles and the parameters, then the regular expression, in this case, are the paradigms and the grammar rules, in this case, function. So you can have for different languages. And in those languages, they were arranged sequentially in each different modules of of the grammar in GF. GF, of course, provide different modules, a module for noun, a module for verb, a module for idiom. So in each module, they were arranged sequentially. So with that, we were able to compare the two generalized grammar, and therefore similarity. You can compare for different languages. We have more than one. And from there, we were able to get a match, and where it was matched, this was the shared grammar or another synonym concrete grammar. Where it could not match, then the remaining portion we looked for, do the structures, can they be similar? Then that was if it was, then that was a case of a portable grammar. Where it wasn't, then in that case, that was a unique grammar. So in this case, we had three sections of the grammar: the shared grammar, the portable grammar, and the unique grammar, which makes the whole grammar for bound parametric together with the unique. And therefore, with that, after that was meant, we were able to test and evaluate. Then we could see. So, in terms of testing, uh, each functions in grammatical framework in the abstract, there is a comment on what it can pass in English. So that was used as the test data. It was applied to experts and inform uh, linguistics who translated them to either ekigusi or kikamba, and that was also subjected to a linguist to check the correctness, and that formed the gold standard. Now, that um comment was subjected to the grammar, therefore, it was to translate to that specific grammar. So it's through linearize and you get the output. Then you compare the two outputs. Okay. If they match, that means that function or that paradigm works well. If it doesn't, there is no match, then you analyze the error, then you fine tune the function or the rule or the paradigms, and then you cross check again. You subject the comment again to the grammar, and you get to the output, and you repeat until there is a match, and then that's when you end. So after all the functions and the paradigms were subject to this testing because we wanted to check the correctness and improve the accuracy. After all it was done, then we evaluated our ability to use the cross-linguistic similarities to produce results. Generally, there are three metrics that have been accepted to measure cross-linguistic similarities used in making grammars, computational grammar. There is the shared rules. You measure the number of shared rules. Then also you measure the number of rules being modified. Either you delete or you add or you change the structure. And then there is a development time. In our case here, we used shared rule and modified rule. Shared rule was used in grammar sharing, and modification rules was used in grammar porting. However, development time was not used because different authors have said it is never exact. It's actually estimation. And in fact, the same old developer at different times will do will do the same work at different time because of the expertise. Probably started as novice, and as it goes on, it becomes better. So you cannot estimate that time and be accurate. Again, most of the authors have estimated the time, so it has never been an accurate measure. So that's why we use the shared rules and modification rule. In terms of our grammar, we counted the number of rules and then we converted them into percentage. It's the same case with the linear relation categories and the same thing with parameters and paradigms in this case. Uh, In terms of morphology, of course, there were 35 categories, and all of them, in terms of linearization, shared. There was no difference between Kikamba and Kigusi, so they shared. While in terms of paradigms, which are the regular expression for morphology, 65% of them were shared, while 14.29 were portable. The structures were the same. It's only the content was different. In terms of parameters, at least 68% was the same, while portability was 18%. That means the unique work done was actually the 20 in paradigms and 12.5% in paradigm. In essence, what we are saying is that if you were to bootstrap a different grammar, then 14% of paradigms will be ported, and the work you'll need to do manually will be 20%. Likewise, here to be portable will be 18% and 12% for unique. In essence, by the time you start, a 65.3 work is already done and in paradigms, and 68.75 work is already done in parameters. In terms of syntax, we counted the rules in terms of the GF modules, and we implemented 163 rules, and 146 rules were shared, while 17 rules were ported. In this case, there were no unique. However, in terms of porting, Cucumber has got a comparative adjective at morphology, while for Ekigusi is a syntax. So this meant the difference in terms of adjective and adverb, and also the progressive file for Cucumber implementation is different from that of Ekigusi. In terms of numero, uh, Ekikusi numero start from 0 up to 5, and then 6 to 7, they repeat. So in this case, 6 would be 5 and 1, 7 would be 5 and 2. And therefore, as a result of that, this explain why there was a lot of difference in numero in terms of the rules because of the numbering system, different numbering system between uh, Kisi and Ikamba. In comparison with other grammar sharing projects that has been done, we can see this bundle projects has done very well despite Ekikusi coming from the western bundles in Kenya and Kikamba coming from eastern bundle in Kenya. It was able to produce in terms of syntax, which all this is compared in terms of syntax at 89%, at least 89%, while this produce 75, other 70, 65, or the language which came nearer to ours is the Scandinavian languages, which reported a sharing of 90%, which was greater than ours. However, this was quantified using lines of code written in each GF module rather than the number of rules. So the sharing percentage, the metrics was different as compared to ours. However, it did well and is similar ranges with the bundle parametric grammar. In conclusion, what we are saying is that if we were to bootstrap a new language, we would expect to start from somewhere, and we expect in terms of linearization, paradigms, and parameters and syntax, at least this would be covered. We would need to port 14% of the parameters, 18% of the 14% of regular expression of paradigms, 18% of the parameters, and 10% of the syntax rule. Finally, the key work that would need to be done, particularly would be the unique work for new language would be 20% on paradigms and 2% on parameters. Therefore, would have reduced the work significantly. Therefore, the rule-based method would have reduced the labor density and the slowness on how to make this computational grammar by just using the cross-linguistic. Therefore, we can conclude that leveraging of these cross-linguistic similarities of principal as parameters significantly, as shown above, reduces the multilingual grammar development effort by using the grammar sharing and grammar porting for Kenyan Bantu. Thank you. And questions and answers time.